Hello friends, we are studying beta and gamma functions, and last time we have defined beta function and gamma function. We have obtained some transformations of beta and gamma function. I have written some results that we have studied last time. This is the definition of beta function. Beta of L and M is equal to integral 0 to 1 x to the power L minus 1 into 1 minus x to the power M minus 1 into dx. The same beta function can be transformed in this form that we have studied last time. And one more thing we have studied is the relation between beta and gamma function. So this is the relation between beta and gamma function. Beta of L and M is equal to gamma of L into gamma of M divided by gamma of L plus M. Now we shall study first other transformations, and then we shall study duplication formula of gamma function. So first we shall consider a few more transformations of beta function. See, in this we have first as, say, we have beta of L and M is equal to, this form I shall consider, that is integral 0 to infinity y to the power L minus 1 divided by 1 plus y to the L plus M into dy. And this we shall write as in two parts, integral 0 to 1 of y to the power L minus 1 divided by the same 1 plus denominator is 1 plus y to the L plus M into dy, plus we have to use the properties of definite integral. Integral a to b can be written in two parts, a to c plus c to b, and thus it is the total range is 0 to infinity. We are writing 0 to 1 and then 1 to infinity. The integrand will be the same, that is y to the power L minus 1 divided by 1 plus y to L plus M into dy. Now we shall suppose this as 1. The left side is beta of L and M. In the second integral we put the substitution because we want the limits to be same. In second integral on RHS, we use the substitution, put y is equal to 1 by x. And if you use this substitution, the corresponding changes we have to do, as we have to change dy to dx, and we have to put this value of y in terms of x and also check the limit. So if y is equal to 1 upon x, what is the derivative here? 1 into dy, and on the right side 1 by x square into dx. And also you may see 1 plus y will be 1 plus 1 by x, or that will be x plus 1 or 1 plus x divided by x. Check this addition, and what will be reciprocal of this? Therefore 1 upon 1 plus y will be x divided by 1 plus x, because we want here 1 plus y is at the denominator. So this is the term we have. And now what about the limits? So the limits when x is y is 1, what is x? See, y, the original limits of y 1, and then x is also 1. And when y tends to infinity, what about x? If y becomes infinite, then x will approach towards 0. So that is 1 over 0 is not defined, but when the quantity is very less, this y will tend to infinity, and therefore we can write y tends to 0, infinity, x tends to 0 are the upper limit for x, and thus from 1 the integral will be, therefore from 1 we have we shall consider this integral uh, unchanged, and we have to write this integral, or yes, from 1 only the second integral we have to consider. Therefore the second integral of on RHS of 1 is, or we can write as integral 1 to infinity, this second integral 1 to infinity y to the power L minus 1 divided by 1 plus y to the power L plus m dy. Now this becomes, new limits are 1 to 0. We are changing, we are using the substitution. So this integral, second integral now becomes, limits are 1 to 0, and this is y to the power L minus 1. Y is 1 by x. So that is 1 by x to the power L minus 1. And now you see, it is 1 upon 1 plus y. 1 upon 1 plus y is x divided by 1 plus x. So we should write as the same, x divided by 1 plus x, and this will be raised to the power L plus m, because it is at denominator, and we have written it in terms of 1 plus y at denominator. So it will be, this raised to L plus m means x divided by 1 plus x raised to L plus m. This is L plus m. And into dy. dy is minus 1 upon x square into dx. So this is minus 1 upon x square into dx. This is the second integral, and therefore this can be simplified. So it is integral 0 to 1. Now you see, what is the power of x, total power of x. The power here, x is at denominator, so this will be negative, means the power of x will be minus L plus 1 for this. And here it is at the numerator, so power is the same, L plus m. Using the laws of indices. And here x is at denominator, so the power is negative, minus. And thus, what is the power of x is, it is L cancels, and m minus 2 plus 1 means m minus 1. So it is x to the power m minus 1. And at denominator 1 plus x. 1 plus x is having the power L plus m into dx. And but we should eliminate this negative sign by interchanging the limits. Limits here it is 1 to infinity, 1 to 0, and I have written 0 to 1. The negative sign eliminates into dx. So this is the value of the second integral in 1. And now we use this in 1. And therefore we can now write, therefore from 1, what is the left side? Beta function. Beta function of L and m is equal to, on the right side, no change in the first integral. We have done the changes only in the second integral, and that we have obtained here separately. So this as it is. And this integral now, or we may first write in terms of y. 0 to 1, y to the power L minus 1 divided by 1 plus y to the power L plus m into dy, plus now this is the integral. Here we have changed, it is integral 0 to 1, which was originally 1 to infinity, but now after substitution it becomes 0 to 1 integral 0 to 1 x to the power m minus 1 divided by 1 plus x to the power L plus m into dx. And now we may see the indefinite integral, the variable of integration can be changed, and both integral we write in terms of x only, or both can be written in terms of y. So this integral we will write in terms of x, replace y by x. And thus what is the left side? It is beta of Lm, and thus this is beta of Lm can now be written in terms of gamma. Gamma of m, L into gamma of m divided by gamma of L plus m, and that is equal to the integral 0 to 1. Now we can add these two integrals at the same step, because the integral limits are the same. this may be written in x, and if you write it in x, this will be x to the power L minus 1, and this is x to the power m minus 1 plus, and denominator is common, that is 1 plus x to the power L plus m. You know this. This is the other form of beta function, which is can be written in gamma function, or this may also be written in terms of beta of Lm, which is the same. So thus beta function has this form, integral 0 to 1 x to the power. This is written in x, and then these two are added. The denominator is common and limits are the same. So therefore we can add it, x to the power L minus 1 plus x to the power m minus 1 divided by 1 plus x to the power L plus m into dx. So this is one transformation of beta function. Now second we shall consider as, we will write this same beta function in terms of this y, or it may be written in terms of x. So I shall write this in terms of x. Variable can be changed. We may write it in terms of x or y, but I shall consider it in terms of x. And now I put x is equal to, here substitution as x is equal to ay divided by b. Now corresponding changes, dx will be a by b into dy. And what about 1 plus x? So 1 plus x will be 1 plus ay divided by b, and you see this will be b plus ay divided by b. And what will be the reciprocal of this? Therefore 1 divided by 1 plus x is equal to b divided by b plus ay. And what about the limits? You see the limits. When x is 0, see y will be also 0. And when x tends to infinity, y also will tend to infinity. Limits remains the same. Limits of integration remains the same. After checking the limit, we have written this, the limits are the same, and thus now this beta function becomes beta of L and M. So therefore we have beta of Lm or L and M is equal to integral 0 to infinity, limits of integration are the same, and x to the power L minus 1. So x is here, ay divided by b. So I shall write it separately, ay upon b to the power L minus 1. And what is the remaining is 1 upon 1 plus x, reciprocal, or at the denominator it is 1 plus x. And we have written the value of 1 upon 1 plus x, that is b divided by b plus ay. So this whole is raised to L plus m. That means this is raised to L plus m, and that into b divided by b plus ay raised to L plus m into dx. Dx is here, a by b into dy. That will be a divided by b into dy. So this is the integral in transform form. And now we may check the constants here. A is constant and b is constant. We can write the constants outside, but before that, writing the constants, we check the power of these constant. Here a has power L minus 1, and then it is plus 1. So a to the power L is the term of it. And what about b? Now see the power of b. B here is at the denominator, so its power will be negative, minus L plus 1. taking negative of this. And here it is having the same power L plus M. It is at numerator. And here in the last term it is at denominator, so with minus 1 power. And thus B has the power, this minus L plus L becomes 0 and 1 also cancels, B to the power M remains. So A to the power L, B to the power M, integral 0 to infinity, and what are the remaining terms that should be written inside the integral. Y to the power L minus 1 divided by, and this is the term B plus AY, and the power is L plus M into dy. So thus this is the form of beta function we have. But what is the beta function here? As gamma of L into gamma of M. Relation between beta and gamma function. Beta of L and M is gamma of L into gamma of M divided by gamma of L plus M. And thus further this term can be transferred on this side, and it will be at the denominator. And interchanging the sides, we can write the integral as 0 to infinity y to the power L minus 1 divided by B plus AY to the power L plus M into dy is equal to gamma of, this is to be written at denominator. So that is, we may write 1 upon A to the power L, B to the power M into gamma of L, gamma of M divided by gamma of L plus M. Check this. Only the sides are interchanged. This term is shifted on other side. It is at the denominator. And thus we have the transform form of beta function in this form. Actually this is beta function. Beta function is equal to this one. Now again in this integral we shall make further substitution as y is equal to tan square theta. So we suppose this as 1. Now in 1, so put here y is equal to tan square theta. Now put y is equal to tan square theta. What are the corresponding changes? Dy we have to write. Dy is equal to 2 tan theta into derivative of tan theta, that is sec square theta into d theta. You check this. Chain rule we have used. This is dy. And what about b plus ay? That is. And this tan square theta can be now written as in terms of sine and cos. So y is equal to tan square theta, and that is sine square theta divided by cos square theta. And derivative we have written from this. And again dy also can be written in terms of sine and cos. This is 2 sine upon cos theta, and here it is 1 upon cos square theta. So that means this will be sine theta divided by cos cube theta into d theta. Tan sec are written in terms of sine and cos. So this is dy. And what about b plus ay? Also b plus a into y will be b plus a into y is tan square theta, that is sine square theta divided by cos square theta. And this is equal to, we take the LCM as cos square theta, and the numerator will be b cos square theta plus a sine square theta. This is what is b plus ay. And thus we have 1 over b plus ay will be reciprocal of this. And so I shall write here. Therefore, 1 upon b plus ay is equal to cos square theta divided by b cos square theta plus a sine square theta. Now we shall check the limits. We have written this term, we have written dy also, and now the limits. When y is 0, what about theta? Tan square theta is 0, and that means tan theta is 0. And when tan theta is 0, if theta is equal to 0. So therefore, when y is 0, theta is 0, and upper limit, and when y tends to infinity, when y tends to infinity, upper limit is infinity. And what about theta? Theta will tend to, we know pi, if theta tends to pi by 2, then tan theta tends to infinity. So therefore, theta tends to pi by 2. These are the new limits, 0 and pi by 2. We should check the limit according to this substitution. So from substitution only we are doing all the changes. And thus from 1, what we have, integral, this integral becomes in the form integral 0 to pi by 2. Y is sin square theta upon cos square theta. So that is sin square theta divided by cos square theta to the power L minus 1. And this is 1 upon b plus ay to the power L plus 1. So 1 over b plus ay is this term, and that we can write as cos square theta divided by b cos square theta plus a sin square theta, and this is raised to the power L plus m. And dy, what is dy is here 2 sin theta upon cos square theta. So I shall write into 2 sin theta, 2 sin theta divided by cos cube theta into d theta. So this is inside the integral, this is multiplied. And what is the right side, or we shall simplify this, this is equal to, now you see the powers of cos, sine at the numerator, sin square theta raised to L minus 1. So this will be sine to the power 2L minus 2, and here it is plus 1 power. So therefore the total power of sine will be sin theta to the power 2L minus 2 plus 1, and that is 2L minus 1. So that is integral 0 to pi by 2 sine to the power 2L minus 1, sin theta to the power 2L minus 1. And what about cos power? Now see the power of cos. Here it is negative, minus 2L minus 2. This is negative, it is at the denominator, therefore the power of cos will be, at numerator it will be negative, minus 2. So minus 2L, and minus 2 minus 1 is plus 2. And here it is positive, it is at the numerator. So it is 2L plus 2M, plus 2L plus 2M, and then it is at the denominator, that is minus 3. We have to use the laws of indices only. Power of cos here is minus 2 plus 2, and so on. So here we may check, this term becomes 0, and 2m minus 3 plus 2, that is 2m minus 1. So this is cos to the power, cos theta to the power 2m minus 1, and thus we have written sine and cos terms. And now what about the denominator is the same, this is the same, divided by b cos square theta plus a sin square theta, and this is raised to the power L plus m, and this 2 is remaining, 2 into d theta. So that 2 is constant, can be written outside the integral. So this is equal to 2 into d theta. And what is the right side? Right side is this one. So is equal to, this is equal to 1 upon a to the power L, b to the power m into gamma of L, gamma of m divided by gamma of L plus M. So this is another form of that beta function in terms of gamma. So this is what we have obtained is this form, or we may say this is the relation we have obtained between beta and gamma functions in terms of sine and cos. And this is one more transformation we have obtained. Now we shall consider the next one. Next transformation as the fourth one we will have, or this is the second, and now we shall consider the third transformation. We have beta function original form. Beta of L and M is equal to integral 0 to 1 x to the power L minus 1 into 1 minus x to the power M minus 1 into dx is the beta function. Here the substitution we shall use is x is equal to sine square theta. So we put x is equal to sine square theta, and earlier we have put y is equal to tan square theta here, but the integral was differently written, and now we have this type of result. Different types of transformation, different types of results we are obtaining using different substitutions. And x is equal to sine square theta. What are the corresponding changes? Dx is 2 sine theta into cos theta, derivative of sine square theta, into d theta. This is dx. And 1 minus x, you see 1 minus x will be 1 minus sine square theta, and this is equal to cos square theta. So thus these are the changes. And what about the limits? When x is 0, what is theta? 0 is sine square theta, sine theta is 0, so therefore theta is equal to 0. And when x is 1, what is theta? Sine theta is 1, so therefore theta is pi by 2. So these are the new limits, and now we use these limits in the original function, beta function, and therefore beta function will be beta of L and M is equal to, the limits here are, now the limits are 0 and pi by 2. So therefore we have the limits 0 to pi by 2. And see x to the power L, x is sine square theta, sine square theta to the power L, and 1 minus x is cos square theta, so that is cos square theta to the power M minus 1. So this is L minus 1, and this is M minus 1 into dx. What is dx? You see here 2 sine theta into cos theta into d theta. So this is multiplied by 2 sine theta into cos theta into d theta, and we shall simplify this. So that is beta of L and M is equal to, see the powers of sine and cos separately, and that will be beta of L and M is equal to 2 is constant, can be written outside the integral, 2 integral 0 to pi by 2. Sine is here the power is 2 and raised to L minus 1 means 2L minus 2, and here it is single power, that is plus 1. So it is 2L minus 1. Sine theta to the power 2L minus 1. And check similarly, the power of cos will be cos theta raised to 2M minus 1 d theta. And therefore we have the result as this integral 0 to pi by 2 sine theta raised to 2L minus 1, or sine theta to the power 2L minus 1 into cos theta to the power 2m minus 1 into d theta is equal to half of beta function. And half of beta function we can write half of beta function now can be written in terms of gamma. Gamma of L into gamma of m divided by gamma of L plus m. And thus this is a result we have obtained. And this is important result in terms of sine and cos. Beta function is expressed in terms of sine and cos, and that is again expressed in terms of gamma function. So we consider this as our first result in this part, third transformation, first result. And further we can rewrite the result writing 2L minus 1 equal to P and 2M minus 1 is equal to Q. That is, now you see 2L minus 1 is P means what is L? L will be P plus 1 by 2 and Q is or M is Q plus 1 divided by in 1 we get. So what we shall get is this as integral 0 to pi by 2. We are not making substitution, we are only changing the parameters L to P and Q. And 2L minus 1 is on left side we write directly this as P and Q, and on the right side we have to put these values of L, M in terms of P and Q, and we get the integral 0 to pi by 2, and that is sine theta raised to P into cos theta raised to Q into d theta is equal to what is the right side is half or 1 by 2, and that is gamma of L, the numerator I shall write gamma of P plus 1 by 2 into gamma of Q plus 1 by 2 divided by the denominator is 2 times gamma of L plus M, and gamma of L plus M means addition of these two, and that is P plus Q plus 2 whole divided by 2. So this is the result we have obtained. Now we have to remember this also. It gives the expression in terms of pth power and qth power of sine and cos respectively, and in terms of gamma function. So this we may assume as second result. So these are the important results we have obtained. Now one more result can be obtained as a corollary to this transformation. See, we can write a corollary. Put here as P and Q both equal to 0. Put P is equal to Q is equal to 0. Or if instead of put you can write if P is equal to Q is equal to 0, then from 2 we have, see the left side, integral 0 to pi by 2. This is sine to the power 0 is 1, cos to the power 0 is 1, and therefore it is 1 d theta. And on the right side, P is 0 means gamma of half, Q is also 0 means that is also gamma of half, and at the denominator it is 2 into P and Q both are 0, that is 2 by 2 it is gamma of 1. So this is the result we have. And again from this, the left side is integral of d theta, which is theta only, and the limits are 0 to pi by 2. And on the right side it is gamma of half whole square divided by 2 into 1, because we know gamma of 1 is equal to 1. And now you see the left side, it is upper limit is pi by 2, lower limit is 0, so this is only pi by 2, that is pi by 2 is equal to gamma of half whole square divided by 2. Multiply both sides by 2, this half cancels, and that is pi is equal to gamma of half whole square, and this gives the, take the square root, therefore gamma of half is equal to square root of pi, taking square root on both sides. This is the relation we have, or the value of gamma of half we have as root of pi. So these results are important and to be remembered. Now what we shall further consider is the duplication formula of gamma function. Now I shall write duplication formula as here, or a result or a theorem can be written. If m is positive integer, then we have gamma of m into gamma of m plus half is equal to root pi divided by 2 to the power 2m minus 1 into gamma of 2m. This is the result that we have to prove. And for this purpose, we shall make use of this result also. We use gamma of half is equal to root pi, and this first result we shall use. That is integral 0 to pi by 2, etc. Now we start with that result. The proof for this, we have integral 0 to pi by 2 sine to the power 2l minus 1, sine theta to the power 2l minus 1 cos theta to the power 2m minus 1 into d theta is equal to half gamma of l gamma of m divided by gamma of l plus m. In this result, we suppose this as 1. Here also suppose it as 1. And now we know gamma of half is equal to root pi. So first we shall put 2l minus 1 is equal to 0, that is l is equal to half. So yes, take l is equal to half in 1. These are the values, parameters, and we can take at our choice, positive values. So l is taken as half in this result. So what this becomes is 0, and sine theta raised to 0 is 1. So therefore the integral only remains in terms of cos, and gamma of half here is root pi. So we get as integral 0 to pi by 2. This is 1 and this is cos theta to the power 2m minus 1 into d theta is equal to, on the right side it is gamma of half, and that is half, gamma of half is root pi, and this remaining as it is, gamma of m we have not changed, only we have put the value of l as half, m as it is, no change in m, and this is m plus half, gamma of m plus half. Yeah. So thus this result we shall assume as second. Now again in 1 we shall put l is equal to m now. In 1 take l is equal to m. Now take l is equal to m in 1 in first equation. So what we shall get, you see, in this l is m, so this is in terms of m, and integral 0 to pi by 2 sine theta, if l is m, both will have the common power, and therefore I shall write sine theta into cos theta whole raised to 2m minus 1, sine theta into cos theta whole to the power 2m minus 1 into d theta, left side, and on the right side this is equal to l is m, so it is gamma of m into gamma of m, that is gamma of m whole square divided by this is gamma of 2m, and this is 2 into gamma of 2m. So this is the result we have obtained by taking L is equal to M in 1. We verify this. This is the same power, so we have written sine into cos. And now we shall interchange the sides. That is, I write this as the left side, gamma of M whole square divided by 2 into gamma of 2M. And on the right, this as right side, but we want to make use of a trigonometric formula, that is sine 2 sine theta into cos theta. That becomes sine 2 theta. So therefore I shall consider 2 here, and if I consider 2 here, 2 will be with power 2m minus 1, and that is extra term is to be cancelled. So this side I shall write 1 upon 2 to the power 2m minus 1 into integral 0 to pi by 2. It is 2 sine theta into cos theta raised to the power 2m minus 1 into d theta. Now verify this. This is 1 over 2 to the power 2m minus 1, and this is 2 to the power 2m minus 1. These two terms cancel, and sine theta into cos theta remains as it is. The value is not changed. Why we have written this? Because now we will write this as sine 2 theta, and thus this is equal to 1 upon 2 to the power. This 2 may be written on this side, and or we may write as it is 1 upon 2 to the power 2m minus 1, and this is integral 0 to pi by 2. This is sine 2 theta into raised to sine 2 theta raised to 2m minus 1, or to the power 2m minus 1 into d theta. Now we shall make the substitution. 2 theta is equal to z. Single angle we want, and thus we put 2 theta is equal to z on RHS, and therefore this corresponding changes will be d theta will be half dz, and if when theta is 0, z is 0, and when theta is pi by 2, what is z? Z is double of theta, means pi. So therefore this becomes, this integral on the right side becomes, and therefore we have that as so I shall write here. The left side is the same, gamma of m in whole square divided by, that is 2 into gamma of 2m is equal to, on the right side it is this side, this is 1 upon 2 to the power 2m minus 1, and now the limits 0 to pi by 2 are now z is 0 to pi, integral 0 to pi sine z, sine 2 theta is z, transformation of the integral, to the power 2m minus 1 into dz, d theta is half z into dz. So it is not z but half dz. 2 d theta is equal to dz. 2 is taken on this side, so it is half dz. So this is half dz, and thus again we can take this 2 with this term, or this half and this half cancels, and we can now write that is gamma of m whole square divided by gamma of 2m is equal to 1 over 2 to the power 2m minus 1 integral 0 to pi sine z to the power 2m minus 1 into dz. Check this half and this half is cancelled and remaining is written. So this is the term we have obtained. Now further I shall continue here, that this can be written as, now the left side integral is 0 to pi. We want to convert this integral in terms of 0 to pi by 2. and for that purpose we shall use a property of definite integral, and that is equal to, the right side is written as 1 upon 2 to the power 2m minus 1, and that will be double integral to integral 0 to pi by 2 sine z to the power 2m minus 1 into dz. Now how this is so? See, using the property integral 0 to 2a fx dx is equal to integral 0 to a fx dx f of x into dx plus integral 0 to a f of 2a minus x into dx. This is used here. Now how it is so? This is the property of definite integral, and therefore what is here 2a is pi, and means a is pi by 2, and f of x is, we are using this result for this integral, and f of x is sine z to the power 2m minus 1, that means f of z, and so that will be integral 0 to a. 0 to a means 0 to half, the same function sine z to the power 2m minus 1, and what is the second part? That will be integral again 0 to half range, 0 to pi by 2 sine, and it is sine 2a here is pi, and therefore this will be, or we may consider so integral 0 to pi sine to the power 2m minus 1 sine z to the power 2m minus 1 will be equal to integral 0 to pi by 2. It is the same sine z to the power 2m minus 1 plus again 0 to pi by 2 half range, pi becomes, we are using this result for this integral, and what is this? F of 2a minus x. What is 2a here? Pi. So this will be sine pi minus z, and that is power is the same 2m minus 1 pi minus z into dz. Now you see sine pi minus z is same as sine z, allied angle formula. Sine pi minus theta is same as sine theta, so this is sine z, this is also sine z, and therefore this integral becomes double of this. So for this, from this to this we have used, or that will be, that is equal to twice integral 0 to pi by 2 sine z raised to 2m minus 1 dz, since this sine pi minus z is equal to sine z, and thus we have written this, that this is for your information, so you may put this in bracket, and now we will continue this. That is, this is 1 upon 2 to the power, and left side is this one, so therefore we have gamma of m whole square divided by gamma of 2m, this is the left side, and what is the right side? Right side is this one, that is 1 upon, these two we shall take at denominator, it is a negative power minus 1, and that is 2 to the power 2m minus 2, and the integral is 0 to pi by 2 sine z to the power 2m minus 1 dz. So thus this we have obtained, but this integral which is in sine can be written in terms of cos. So why this is so, that we will see again. So I shall now write that as equal to, this is equal to 1 upon 2 to the power 2m minus 2 integral 0 to pi by 2 sine, I write cos z to the power 2m minus 1. Again the property of definite integral we have to use. So which property is used? This is left side is gamma of m whole square, gamma of m whole square divided by gamma of 2m. Here what is the property used is integral integral 0 to a fx dx, f of x dx is equal to integral 0 to a f of a minus x into dx. This is the property of definite integral. Here this one is used and now this is used. So what is the f of a minus x means sine of a is here pi by 2, sine of pi by 2 minus z. And what is sine of pi by 2 minus z? And that is in the first quadrant of the angle, and that is cos z. Sine pi by 2 minus z is cos z, and therefore it is written in terms of cos. And sine pi by 2 minus z is equal to cos z. So therefore this sine becomes cos here. Under the same power, limits are the same using this property. And now here we shall use the second result. What is the second result? This is integral 0 to pi by 2 cos theta raised to 2m minus 1 d theta is half gamma of root pi into gamma of m divided by this one. And now it is exactly the same integral 0 to pi by 2. Instead of z here, instead of theta here it is z. So therefore its value is to be replaced from second. So using next. Now I shall write here. So using 2 on RHS, we have, or we get, the left side is gamma of m whole square divided by gamma of 2m is equal to 1 over 2 to the power 2m minus 2. And this integral 0 to pi by 2, it is exactly the same here. Its value is half root pi into gamma of m divided by gamma of m plus half. And now you see, 1 gamma of m cancels from either side, and so what remains is gamma of m. This gamma of 2m we shall transfer on the other side, and that is, and this gamma of m plus half we shall take on the left side. Shift the terms, gamma of m, and then this is to be taken on left side, it is at numerator, gamma of m plus half is equal to. Now this gamma of 2m I shall write on the right side, it will be at the numerator, and what is this term is root pi, and what is the power of 2? 2m minus 2, and here is first power, and therefore it is 2 to the power 2m minus 1, and this gamma of 2m is written on the right side. And this is exactly what we wanted to prove. See this. So this is hence the result. And why this is known as duplication formula? Because of this term. It's double. Gamma of 2m. Gamma of twice m. So therefore m is duplicated, and therefore it is known as duplication formula. So this is an important result that we have proved with the help of the earlier transformations. So you should observe these again. We have used the properties of definite integral, verify it, and try to understand the proof. So remaining part we will continue next time. Thank you.